Now, the second part of this question is another sequences and series problem. So, square side lengths 2. The midpoints of each side of the square are joined to form another square, and the process is continued. First 3 squares in the process are shown below. Find the sum of the perimeters of the square. The process is continued indefinitely. Now, once we see it's going to be continued indefinitely, we know we're going to be using this here. Formula here, there's the infinite sign here, so it's sum or your series. So, and in order to use that, we must have A and R. A's being the first term. Now, just be careful, it's the first term of your perimeters. So in this here, we can see that the first term is going to be 2, 4, 6, 8. Our first term is going to be 8. 4 times 2, which is our 8. We just need to get the common ratio for all the other squares. So we're going to use these squares to find the common ratio. Now, if this is 2 and this is 2, they said something about midpoints down here. So in order to find the length of this square, we're going to need the length of the hypotenuse of these triangles here. So if that full thing's 2, that means that each of these must have a length of 1. And it's the same here, 1 and 1. So we form a right angle triangle in which this is 1 and this is 1. Now, using our theorem of Pythagoras, square root of 2. So this is our length of our hypotenuse. Therefore, to find the perimeter of that orange region there, it's root 2 plus root 2 plus root 2 plus root 2, which is the same as saying 4 of those root 2's. So the perimeter of the first one was 4 times 2 is 8. The perimeter of the second one was 4 of these root 2's. Now, we can work out our common ratio from this. You could, if you wanted, work out the common ratio for the next one by just splitting it up into another square here. But just be careful when you're finding the length of these sides, you're going to be using root 2 over 2. So root 2 over 2 will give you the length of these here. Don't worry so much about it. So R, the second term over the first term, 4 root 2 over 4 times 2. You can just simply put into your 8. That'll give us the common ratio here. So 4 root 2 over 8, root 2 over 2. Now we have everything to put into this formula. So your sum of your infinity, A over 1 minus R, if it's continued indefinitely, A being your first term, which is 8, over 1 minus root 2 over 2. And hopefully it'll be in this form here. Yeah. 16 plus 8 root 2, and they're natural numbers, so there's a fair chance we're right.